Hey everybody, in this next video lesson, I'm going to introduce you to a topic known as calorimetry. Now we've already done calorimetry in a lab just a few days ago, but we're going to talk about specifically the topic of calorimetry, the apparatus we use for calorimetry, and the math that we use to calculate using calorimetry. Now together with the three laws that we learned about in the previous video lesson, and the concepts of enthalpy and the change in enthalpy, we're going to put these concepts together when we're talking about calorimetry. Now, we know that Q equals mc delta T, where the energy in joules is equal to the mass times the specific heat times the change in temperature. Well, that will tell us how much energy is lost or gained, actual amounts of joules. But I talked about this in a video lesson, but delta H and Q are similar, but they're slightly different. Delta H is a change in energy, so we don't really know what the energy was at the beginning and what the energy is at the end, but we know how much energy changed, where Q is an exact amount of joules or kilojoules that are gained or lost in a situation. And so what happens is, if we can treat delta H and Q similarly, well, in a situation where a reaction loses or gains energy, we'll call that delta H. Well, we know that the energy lost or gained by a situation is equal to the energy gained by the surroundings. But as we learned about in the laws of thermodynamics, that specifically the second law of thermodynamics, that the energy gained by an object is equal to the energy lost by the surroundings. And so we bring in the concept of the first law of thermodynamics. Q equals negative Q. But now we're going to substitute the first Q with delta H because that's for a reaction or process. The change in energy is equal to the energy gained or energy lost by the surroundings. And so set up a situation with both of these where delta H is equal to negative mc delta T. Where basically what I've done here is I've taken Q equals mc delta T and I substituted mc delta T in for Q here, keeping the negative sign out in front, and we have delta H equals negative mc delta T. And this is the calculation that we use when it comes to calculating how much energy gained or lost happens from a chemical reaction when it's equal to the energy gained or lost from the surroundings with a specific mass, specific heat, and change in temperature. So this formula, delta H equals negative mc delta T, is kind of what we're going to be going with moving forward when it comes to calculations involving calorimetry. Calorimetry is specifically the study of the exchange of heat between the system and the surroundings, the object or the chemical reaction and the surroundings, which could be water or air. Now there's two types of calorimetry. There's constant pressure calorimetry and there's constant volume calorimetry. One is easier than the other, and obviously we're going to do the easier of the two. We're not going to talk a lot about the equal volume calorimetry, but over here we have equal pressure calorimetry, which is what is known as a coffee cup calorimeter. It literally is two styrofoam cups inside one another with an insulated cover. This is very similar to the experiment that we did with the heat of dissolving, which we did last week. But you've got water inside and the temperature of the water is monitored. Now the reaction might be happening inside the water, which may exchange its energy to the water, or maybe it's going to absorb energy from the water. We're going to monitor the temperature change of the water, and that's going to help us determine how much energy was lost or gained from the object or the system or the reaction or what's dissolving inside the water. So calorimetry is a way to indirectly measure the heat lost or gained from a system or from a process by measuring the temperature change. We'll know specifically the mass of the water, we'll know the temperature change of the water, and we'll know the specific heat of the water. So we'll be able to then, because we know the first law of thermodynamics says that the energy lost by a system is equal to negative energy gained by the surroundings, just like I showed you in the last slide, it's that delta H equals negative mc delta T. Well, using this calorimeter and that formula, we can accurately measure how much energy is lost or gained by a system or by a process, whether it be endothermic or exothermic. So you might be wondering, how did we know those numbers from thermodynamic equations? Well, we actually gathered them experimentally using calorimeters. Now, the other type of calorimeter is called a bomb calorimeter, and is also known as equal volume calorimetry. And it is much more complicated and has an element of danger. And in fact, I've never actually done bomb calorimetry myself, and so I will never actually do it in front of students. Well, that takes care of this video lesson. Thanks for watching.